This problem asks to investigate how the internal energy of air changes over a temperature range of 200 Kelvin to 1500 Kelvin at various pressures using the RG model, or the real gas model. So we're going to go to test calcs. We'll use system states because there's no flow in the problem. We're just evaluating the properties at different states. RG model as stated, test app or test calcs, and it said 100 kPa and the initial temperature was 200 Kelvin. So now we'll calculate, and you can see you get your U value for that state, and it's set to air, so we're good on that because that's what it asked for. And now we're just going to keep going, adding increments of 100, or you're choosing, depending on how accurate you want the graph to be. P2, the pressure remains constant, so we'll just go up by increment of 100 until we get up to 1500 like it asks. So that will take 13 different states where we'll be basically doing this same thing. So we'll do state 3 equals P1 again, because that's constant, and then we could either do T1 plus 200 or T2 plus 100, and we're just going to keep doing this until we're at 1500. So I filled these out beforehand so this video wouldn't be 10 minutes long. So I went up to state 13, which ends up being at the 1500 degrees. So some things important to note that were in between each state. When I entered the two values for P and T, I hit calculate after each one, or else it doesn't save. And you might have been wondering why I left this as degrees C. The first one was in Kelvin, and since the delta degree C and delta K are the same, it's a one-to-one value, it doesn't really matter if you change this to C or not, since the first one was in Kelvin. So now we can go to the graphics panel, and it automatically puts it as a TS diagram, but we're looking for the UT diagram. So we'll switch that to UT in the upper left corner, and it doesn't always go right away, so you'll probably have to hit super calculate, which will bring you back to the IO panel, and then you just go back to graphics panel, and there it is. And there's your UT diagram from 200 degrees K to about 1500 Kelvin. You can't see the 200 because those were below zero, as you can see over here. They were below zero until state 4. Alright, and now the second part of the problem asked to evaluate it the same thing, but rather at 1 MPa and then 10 MPa. So how we're going to do that is go back to state 1, drop it down to state 1, and change this to MPa and 1. Alright, calculate, and we'll hit super calculate so that it recalculates all of the states, because each state was based on a P1, which is really important that we put equals P1, because otherwise we would have to go through each individual state and change it to 10 MPa manually, which could have been pretty tedious, and maybe you would have accidentally skipped one, which would cause an error. So now we can go back to the graphics panel, and there is our UT diagram for 1 MPa from 200 Kelvin to 1500 Kelvin. And you can see that all of the pressures changed to 1 MPa or 1000 kPa. Over on the right here, all of the states are at that pressure. You'll notice that it looks pretty much exactly the same. It has all the same Y values, because if you go back to the state panel for pressure 1, say, and look at the U value right here for 1 MPa, it's negative 158.8. If you change it back to the 100 kPa or 0.1 MPa and hit calculate, it's negative 155. So they're really close, so the graphs look pretty similar. Okay, the next part of the problem asks to evaluate it at 10 MPa. So again, we're going to hit 10 MPa, hit calculate first, and then super calculate to recalculate all the states. Back to the graphics panel, and there we have it again. Again, it looks pretty similar. The values probably changed not too much. We can go look at state 1, negative 196. So not too different, but to notice it in the graph, but they are different. And all your values, again, are over on the right, and you can see that it's at 10 MPa. All right, and now the next part of the problem asks, what if the gas was changed to argon? So back to the state panel, we'll change it to argon, which is right there. And then recalculate state 1, super calculate. Unfortunately, the super calculate doesn't always work. Right now I can see that it only switched state 1 to argon and not the rest of the states. You can see it says air right there. So it's important to check to make sure everything went right when you super calculate. So we're going to have to go through each state and manually change them to argon. Make sure to hit calculate in between each one. I went ahead and did that for all 3 states, and now we can hit calculate, graphics panel, and there is our UT diagram for argon. You can see that the y-axis values are much different this time, so it actually made a significant difference from when it was air. We're still at 10 MPa, but you could do this for any pressures following the steps we did before. Hitting join states, we'll draw a line, and you can see that it's linear, showing that argon is a perfect gas.